Hi everyone, welcome back to Mind Over Math. This is part one of how to use completing the square to solve quadratics. There's a part two to follow. We're continuing our discussion on quadratics. This particular lesson is on solving by completing the square. In reality, we are changing the standard form, y equals ax squared plus bx plus c, into vertex form with an a, an h, and a k. Of course, h and k are the vertex. The process we'll start with to review this is solving using square roots, and then later talk about perfect square trinomials. To solve by square roots, we have this first example, which to solve for x, we would divide by 6 and get x squared equals 9. And the reverse of squaring is square rooting, so we would square root both sides. Now don't forget, when you square root both sides, there are two square roots of 9, plus or minus 3. Both are answers, both are needed. Let's illustrate that a little further. We have another problem to solve by square roots. So first we're going to add 4 to both sides. 3x squared equals 72. To get the x by itself, we divide by 3 on both sides. So x squared equals 24. So then, because of the squares, x squared, we would want to square root both sides, and x would give us plus or minus the square root of 24, which breaks down into 2 radical 6. The next problem we're going to do requires a knowledge of the perfect square trinomial. Now you'll notice in this next problem that the term right here is a perfect square trinomial. That is, the first term has a square root, and the last term has a square root. The middle term suits the equation -2 times a times b, which is -10x. So this is a perfect square trinomial. That means it will factor perfectly into a square, which looks like x minus 5, x minus 5, which is x minus 5 squared. So we notice now that both sides need to square root. The reverse of squaring, or solving by square roots, is to square root. So the square root of x minus 5 squared is x minus 5, and the square root of 27 is square root of 9 times 3. The 3 pops out as a perfect square root, and it's a plus or minus 3. So our two solutions are x equals 5 plus 3 the square root of 3, and also 5 minus 3 the square root of 3. Here's another example of the same kind that you may want to practice through on your own paper, doing the same thing. So this next problem, again, this is a perfect square trinomial. So I'll leave that one for you to try on your notes. Next, we'd like to move to the concept of learning how to complete the square, and that is with a formula that is called b over 2 quantity squared. Well, this is my b, and this is my a, which is 1, and this unknown number right here, we're going to put a box there. We don't know what that is. But we're going to determine it with this formula called the completing the square formula, which is b over 2, which would be negative 4 over 2. Quantity squared is negative 2 squared, which is 4. So the number that would go in this box to complete the square is 4. Now I want to remind you that if it does complete the square, that means it is a perfect square trinomial factor. This then would factor into x minus 2 times x minus 2, which we would not want to write that way. We would want to leave it as x minus 2 quantity squared. So here's a second example. X squared plus 5x plus what would complete the square? So we use our little formula, b over 2 quantity squared. The b in this case is a 5, so we're going to have 5 over 2 quantity squared, which is a strange number, 25 over 4. So that's actually the number that's going to go where the question mark is going to be positive 25 over 4. Now we want to factor that, and so the factor, because of what we found, turns out to be x plus 5 over 2 times x plus 5 over 2, which is x plus 5 over 2 quantity squared. This is an unusual perfect square trinomial, but because of this formula, b over 2 squared, it becomes easier to do. So we're going to apply this now to this problem and try to get a perfect square trinomial to complete this box. So we start with our formula, which is b over 2 squared, and rb in this case is a negative 12. So this becomes negative 6 quantity squared, which turns into 36. So that means this problem adds a 36 into the left side, but in equation solving you can't just grab numbers out of the air. You have to balance the equation. If you remember, the first principles of equation solving is you have to keep them balanced. If you don't keep them balanced, you're no longer an equation. So this left side, the perfect square trinomial, factors into x minus 6 quantity squared equals 13 plus 36 is 49. And since we have a perfect square on the left side, we're going to square root, principle of square rooting both sides, and we get x minus 6 equals plus or minus 7. So one answer would be 6, add the 6 across, plus 7, and the other answer would be x equals 6 minus 7, which equals negative 1. Now these are actually the x-intercepts, and I will remind you, and I have these here, I will remind you there are a set of rules that we will look at on the next page. There are 6 steps that we followed on this, and here's what they look like. Now you would be wise to screenshot this. These are the steps to completing the square. Now we're going to notch it up a little bit on this problem. So the first thing I'm going to do, we're going to start on the green problem here, the one on the left, and we're going to bring all of our variables over to the left side. Variables to the left side. So that means I'm going to bring the 6x over to the x squared. And I'm going to leave the 27 right there. Now I'm going to try to figure out what completes the square here. What goes in this box? I'm also going to put a box over here because I have to balance this problem by putting the same number on the other side. Let's use our formula. Our formula is b over 2, quantity squared. RB in this case is a 6, so we have 6 over 2, quantity squared, which is 3 squared, which is 9. So that means this is a 9. Not only is this a 9, this is a 9. Remember, we have to keep this thing balanced. If I come up with a brand new number to add to one side, I have to balance it and add it to the other side. Well, this works out into a great factor because this is x plus 3. There's that perfect square trinomial again, equals 36. So again, if I square root both sides, reversing the square, I get x plus 3 equals plus or minus 6. So one answer is x equals negative 3 plus 6, which is 3, and x equals negative 3, bring that 3 across, minus 6 is negative 9. Now these are the x-intercepts. These are the x-intercepts. That's what they stand for. This is where this graph crosses the x-axis. And I want to show you something at this point that we haven't mentioned before. If we go back to the few steps back here, right at this level, right here, you will notice that this is very close to being in vertex form. If you look at the top of the page here, I told you that we were going to take the standard form equation and we were going to turn it into vertex form. So there's more to talk about that as we go on. In the upper right-hand corner, make sure you subscribe. In the upper left-hand corner, make sure you check out other videos. Likes are below and make comments on topics you need.